Hi everyone, welcome to the Distributed Data Analysis webinar. Thank you for joining us. Just a few things before I give the word to our speakers. If you have any problem during the webinar hearing, please write us attached to communications or marketing. We are going to have a special time for question and answer at the end of the webinar. In the bottom right of the screen, there's a question mark, so you can put your question there, and at the end, the speakers are going to answer that. Our first speaker is going to be Sabina, so I'm going to give the word to her.
Okay, thank you very much for everyone to join this webinar. I will start with a quick introductions to the speakers we have today. Myself, I'm a technical director at Globant. I'm specialized in the backend development, mostly dealing with distributed systems, high volumes of data, data architecture, and data science. I'm going to speak more on the problematic, the different trends in big data in the market. And then I will pass it on to Esteban Lucic. He is more specialized on the data visualization. He's leading the practice currently at Globant. And we have a special guest, Matt McNeil, who is going to speak more on the trends we have at Google at the moment. So once again, thank you very much for your time. Thank you for joining. We have some guests here in Buenos Aires as well. We have Esteban in Uruguay, our office is in Montevideo, and Matt in UK, Google offices in London. So as a quick introduction to Globant, Globant is a development company more specialized on giving different services. We have different studios which hold different practices. Today we are presenting big data as one of the practices inside High Performance Solution Studio. This is a part of the series we have this year with previously UI and UX, for example. We will holding this kind of conversations and webinar along the year. So keep up with our communication channels to see the following ones. These are some of these example clients that we have experience with along this year. As a remarkable characteristic, we grow very quickly. Currently, we are 3,000 employees almost, and we have offices, development offices spread all along Latin America, Brazil, Argentina, Uruguay, and Colombia as well. And we also have a development offices in the US, in the West Coast, and of course presence in different of our client offices in Europe and US. So as an overview of our practice and how we have it structured inside Globant, we have a data architecture pillar, which is mostly focused on the transformation of data, data ingestion, different KPIs, extractions, and metrics. We have a data science, which is if data architecture takes a picture of the current situation on the business perspective. Data science tries to identify different patterns, perform recommendations, so along with cluster and classification, data modeling in a more predictive way. And data visualization on top of that is capable of doing innovation on top of different types of visualization, which Esteban will be speaking a little bit more. Below you will see different technologies we have experience with in this field. The following slides will explain you more on the trends and what we see is happening in the market. But as to give you an idea on our baseline, we've worked together with Google for 6 years now, and we gain a deep understanding of the different architectures and solutions they provide, which actually marks a trend in the market and an evolution starting with MapReduce development to big table, getting through the latest technology, which Matt will give us a profound understanding, as for example, Dremel, BigQuery being the latest technologies in this field. We also have experience in the open source community dealing with all these frameworks. Some others to name, MongoDB, and of course the different other stacks that are out there. On the data visualization part, we are mostly specialized on HTML5 development, which gives us a possibility to implement this type of solutions on mobile and tablet devices. So going into deep what big data is in the market, when we think about big data, we focus more on the volume aspect, but as to state, there are other aspects to take into account. For example, the velocity of the data, so trying to extract metrics in streams of data in real time is something very important to identifying this type of problems. And something also very important aspect is the variety of the data. We try to cross-reference structured data with unstructured or semi-structured data. To give you some of the examples, in the velocity aspect, social networks are one of the most representative examples. Twitter, for example, shows what's happening in the market or what people think about any different aspects of life in real time. So sometimes companies want to extract conclusions based on sentiment analysis in real time, and big data gives you the possibility to do that. On the variety of data, you can think of different log files if you want to cross-reference different relational databases, data that you already have with log files that hold a specific structure or semi-structuredness of the data. You can do that. And along with all these, we will see that this type of solutions deal with different perspectives of the network. You want to avoid all the network latency. When you are speaking about a cluster, for example, this amount of data that we're speaking here about is about terabytes or petabytes bytes of data, and we want to avoid at all means to use one single computer. It's not possible anymore to transform and analyze this amount of data in one single node. So we scale in a cluster, and this type of architecture has several characteristics that allow us to avoid latency in the different networks, or even avoid errors, or provide high availability of the cluster. So how did all this begin? We get different types of information. For example, a transformation in the media market. We get paper that is transformed into digital, mails, or even in this case, a newspaper. We see this happening also in the stores. Physical stores are along these last years transformed into an e-commerce platform, for example, or even radio. You can listen to Last FM, to give you an example. YouTube is also another platform that has gained a lot of the market share lately. Google TV, for example, is another one of the examples. All the proliferation of the social networks gives us more and more digital data that we want to use, and leaves a footprint in the digital market. We have more and more data that is digitalized and out there, so you can use it and take advantage of this. Something to clarify in this type of problems and also solutions we propose is that this type of platforms is not out there to replace what you have, but to actually enrich the information that you hold inside your company, cross-referencing it with public data or even other sources of data that you have that doesn't follow a specific structure. And the idea is to take this data as it is, raw as it is, and take advantage of the value that it can add to you. Another example we can think of is, for example, the sensors, the implications of adding different sensors to mobile, or even actually in this case the cars. Fourth is thinking about incorporating lots of sensors that will give you more information on how the different parts are used, and this will actually help the production of and planning of the production for the different car production. Some other examples we can think of is open cities. More and more government and actually different cities are exposing their data about their economy, how their financial status is, and the different plannings in the construction and infrastructure of the cities. And these are some of the examples of good usage of public data to provide more insight and actually to innovate in democracy in the case of the open data for the government. So about the history, something remarkable to state is that Google along these years has released different white papers explaining the different solutions they have designed internally for their business. And they have released the different solutions that have really marked the market in the last years. The first one is the Google File System white paper, which later on had a response from the open source community, and you will see Hadoop as being the open source solution implemented along the ideas Google published. Bigtable, for example, is a more column-oriented solution that was released 2 years later, the Google MapReduce solution, and you will see MongoDB and Cassandra based on that type of architecture. And the later one, Dremel, actually we currently don't see a solution that is comparable to that type of architecture. Matt will give you some more insight on that, and actually really performs very quickly and has different capabilities that we still don't see in the open source solutions. 2011, you will see that McKinsey released a white paper explaining the big data benefits mostly on the business side, and really marked the market in exposing this concept into our companies. 2012, we see a trend on the big data visualization tools, and 2013 is something that we are expecting on the different trends to see the proliferation of platforms that will allow us to provide this type of metrics and conclusions closer to the business side. Currently, we need a good bunch of very technical guys to help us extract this type of metrics and solutions, which we expect to see more abstraction and help from the business side to expose this type of drill downs and do more type of analytics. So the benefits we see overall is to get a better understanding of the world, tracking the productivity, improving effectiveness in the different economical aspects, performing a discovery phase on the different patterns, predictions, optimizing the hardware usage, and reducing the network traffic problems. These 2 points are remarkable in all the architectural designs. They try to avoid the usage of the network as it introduces latency. So we try to optimize the time in which data is transferred along the different nodes. And of course, optimizing the hardware in the sense that we rely on as little as possible in the hardware. We count on the hardware will fail. So we propose solutions in which replication is a must, a requirement. To move on the different tools, we see this is a high-level architecture of the ecosystem we see currently at big data. We have different tools, as for example, Flume or Scoop, that will allow us to interact with the outside world of a platform like this, will allow us to transfer huge volumes of files and interact with relational databases, as an example of Scoop. But we also have other abstractions on top of central repository, as it could be Hadoop, as the HDFS. One of the examples is Hive, that build different tables, abstractions on top of plain log files to allow us to query in an SQL-like language the different metrics we want to extract out of them. So a comparison on the different tools that we see currently in the market, we see that relational databases are very suitable, of course, to perform transactions and to continue with the core business of the different problems we have at the companies. But in a matter of availability and actually to scale out in the capabilities of storage and analysis, we see NoSQL databases are more suitable. At the moment, we see that according to the consistency, availability, and also scalability aspects, we don't see a solution, but I will give Matt the opportunity to show that Google has some insight that actually fits into the three of these characteristics. But on the open source community, we don't see a solution that fits into the three of them. So this type of solutions and frameworks are more suitable for analytics in real time or batch oriented. They are not as good as dealing with very little volumes of data. We tested Hadoop, for example, with very small files, and the actual performance is not as good as if you have large volumes of files and large in size themselves. Also, mixing up different structure and unstructuredness of the data is important. Some of the frameworks we want to name that are taking place and more importance in the market are, for example, Storm for real-time analytics. It proposes a schema in memory that allows you to take input from different data sources, different streams of data, process them, and put the output available for you to actually visualize them or consume through different APIs, for example. Some of the platforms that we see are taking more in the market, and we are expecting to see this type of solutions coming in this year and the following years, are the ones that will put the analytics tools and all the real-time drill down and transformation of the data. As for example, Platform is one of them. You can ingest the data and you can actually, more in a business intelligence tool like actually drill down and visualize data in real time without the need to develop more scripts or different type of queries to cross-reference different data sources. Finally, we also see more platforms taking place in the market, as for example, Hunar, that ingests the different data and has different dashboards and visualization tools available that allows you to publish this type of data. Lots of cities and government in Argentina are using this platform to publish their insight. So along with the data science, which is more predictive type of analytics, we see that this type of models and algorithms has been out in the market for a long year. Most of them are actually dated on the 17th century. And they are oriented on pattern recognition, machine learning. So you have a test data set, a training time, and then you expose the different mathematical models on different quests, and you will get an answer on the type of classification or clustering or even recommendation you want to apply. So it really involves trying to capture the reality in a more scientific way, and it is difficult. There is a lot of already implemented algorithms in the market, but the current problem that we have is to try to scale this type of solutions to a more actually that can deal with bigger volumes of data as we have in the moment. These are some of the examples we have at Globant on face recognition or iris recognition. Some others that we can think of is trying to study the human genome, or something that Amazon is doing for a long time now, and many other sites as well, is recommending different products along with the different preferences that you have according to historical data that you have on different bots. are some of the examples to give you an overview and to actually close this part of the presentation on the clustering of data and along with a specific example on support vectorial machines. In this case, we see two types of groups of data, one green and one red, and it's very easy to identify the two types of groups that we have. But if you want to classify the black dot that you have there, which group will be actually belonging to? So a type of algorithm like this will classify and identify very quickly these two groups. And it will optimize the line that will draw, but actually it depends on the error that you want to this prediction to be set. The line could be set in all of the gray ones that you can see there, but the optimal line is the blue one stated there. And what happens if you have a mixture of the different groups, so the green and the red one, and you want to see the black points, which one belongs it to. The algorithm will be trained in order to identify the two groups and actually draw a line which classifies the black dot. And all this happens, it takes a lot of time for the algorithms to train. There are lots of implementations already in the market. You can see it R as one of the trends at the moment. It has been developed by different universities in the world, and it has a huge community that is supporting it and has lots of these algorithms already implemented. And you can use it on top of Hadoop, for example, to do patterns recognition and predictive analytics. So now I will give it to Esteban to continue the presentation on the data visualization part. Esteban, now yes, we can hear you.
Okay, let me know. So, well, I've been very engaged into data visualization practice since the beginning. Well, since I'm from a more visual area, I'm gonna talk a little about the data visualization practice and, well, what is data visualization exactly. So let's go quickly through the slides. As you can see, this is data visualization. It's not very appealing, no matter how much we love Microsoft Office, but we can turn that into a more engaged experience. I'm sure football fans will love this example. So the idea is to detect what areas of the discipline could be improved in order to deliver a set of data and accomplish the desired objectives. So in the second example, as you see, there's a good use of iconography. I don't know if you can see, but you're seeing the team shields. There's a good use in color palette. There's a good use in layout, padding and margins, the sorting of the data that is being displayed. So the idea for this practice is to try to leverage all the visualization practices throughout the graphic design and web best practices in order to deliver a very complex data set or data collection into something engaging for the user and understandable and usable. And well, data visualization could be part of many things. It could use of charts, gauges, grids, maps, dashboards, storyboards, also illustrations and infographics. They are all part of this discipline, and it all could help to get into a good data visualization practice. One point about infographics that it's worth mentioning is that they are sometimes confused with the charts themselves or illustrations or whatever. But actually, infographics is the practice itself of showing information. So an infographic could also tell a story, or an infographic could guide you through I don't know, through a museum, inside a leaflet, you know. So infographics are not always talking about data, or at least not a big data, big volumes of data. So it's worth mentioning the difference. There are several examples here. This one I find it particularly interesting because it's dated 1869, which is more than a century now. So data visualization has been around for a long time, and the interest in understanding data and process data and big volumes of data of that time was already present. This is a very engaging example, and I encourage you to read through later in the recording of this webinar. But basically, they are describing the Napoleon's army campaign in Russia and how did it go. They did it badly, by the way, but it's worth mentioning that the data visualization as a practice has been around forever, and now we have even powerful tools from the web and from other devices to interact with the data itself and make it more complex, so that we can compass all the times and the requirements from the users to get this data more quickly and more engaged at the same time. So what we have now is a lot of new devices to work on. Sabina mentioned we have seen an exponential growth in all the outputs that we need to address regarding big data. So there's a necessity for the user and for the developer to create and develop innovative ways to deliver that data. People no longer access this data from its desktop machine, but also from a tablet and mobile device, or even from the TV itself, sitting on his sofa. So many more interactions and many more visualization frameworks have been developed to address this necessity. Here are a few examples. Technology itself has evolved also in terms of what can be done, what can be made possible inside a computer screen or a device screen. So there are very stunning examples of big data manipulation, turning into almost artworks, and at the same time describing a behavior or a tendency. So the data visualization has grown a lot. Inside Globant, and with this I finish my part, we have developed the data visualization framework. It was an internal initiative to leverage all the effort that we have put inside the practice, and recognizing all the patterns, all the common patterns between projects, all the pain points that have been through regarding the delivering of a dashboard, a data dashboard that could deliver the final client reports, metrics, and KPIs to work on. So the idea was to develop a framework that could take the user to select different layout types with different interactions. You can drag widgets, reports from one to the other on a grid-based layout or even a free layout. The data could be easily connected to backend engines. Also, special abilities inside the widget to drill down specific portions of data. Of course, view the raw data into a table format. maximize a widget to have it full screen and have a detailed view of the data represented. Filters applied into different criteria with different metrics, and well, of course, incorporated all the last modern web tools so that dashboard could be accessible from different devices, and also try to increase performance, and at the same time make it as engaging as possible to the final user, so that we can adapt to the business requirements, to the client requirements, both from a data perspective and from visual perspective. So that's pretty much it. Here's a snapshot of the dashboard framework. This is a raw implementation, so a demo, but you can see all the features that I had described: filters, widgets that can be dragged, so on. And well, that's pretty much it. Let us know then if you have any questions regarding this. Thank you very much.
Thanks, Esteban. I hope everyone can hear me okay. Thanks very much for inviting me to speak today. It's very interesting to see so much which is coming out over the last couple of years around big data. And what I'd like to share a little bit today is some of the background to what we've been doing in Google over the last few years. I work in Google's infrastructure practice. We are focused at the moment on a major strategy which we've been executing on in the last 18 months to look at externalizing Google. But before I start that, I thought I'd just give a little story which might sort of illustrate to some extent the importance of data as a whole and what Google actually thinks about data. Yesterday I was reading a book, actually, a friend of mine lent me. It's a book on Alexandria, and we were arguing about, actually, it's something to do with collaboration, the impact of collaboration on communities. He says, you've got to read this book. And what you find is, today it's very easy to get hold. I get my phone out, and within 10 minutes, and for the price of 3 cups of coffee, I'm able to order that book, and it arrives on my doorstep for me to read within 24 hours. And to be honest, that's quite an incredible thing to happen, because in a way, Alexandria, and what happened at Alexandria, what Alexandria became famous for, was of course what happened to knowledge within that example. Alexandria is famous because, in a sense, the burning of the Library of Alexandria marks a transition for humanity. As it moved really from the classical world into what we now call the Dark Ages. And this is marked by something very specific, is knowledge becomes very difficult to find. And in fact, in this era, if you had wanted to go and find a book after the burning of these libraries, often you would end up walking for several months across continental Europe to find some remote monastery in the mountains where you would find books chained to the bookshelves because they were so important to people and so valuable. And in a sense, the progress of humanity is held back for almost 1,000 years because of this lack of access to knowledge and information. Now, what you see breaking this situation is quite an interesting thing. Is the printing press, which was invented in 1440. It's very interesting to say that after that invention, within 60 years, 20 million books are printed and distributed across the Western world. That is an incredible number in terms of the sharing of knowledge and information. And in fact, we argue today that really the birth of the Renaissance, the flooding of texts across Europe at that point in time, led fairly directly to the Industrial Revolution, and beyond that into the technical revolution that we all participate in some way or another today. Now, the other side of that coin actually is also to do with the printing press, because if you take the amount of data that has been produced by humanity from that date in 1440 to about the year 2005, 2006, it's about 12 exabytes. And we produce that amount of information and data almost every 2 days today because of the proliferation of data generating devices and sensors, smartphones, and all those other bits of equipment that we have around us today. The generation of information has exploded, and in a funny way, it's almost bringing us full circle, because it's becoming as hard to find information today of value, not because it's remote and halfway across Europe, but because we're flooded in it, and it becomes a bit like trying to find a needle in a haystack. And I think really it was that insight that led to Larry and Sergey some 14 years ago, their recognition that the web itself was an information source that was growing exponentially. And within a very short space of time, the approach which was common at the time of curating information and putting them into search engines, in some ways quite labor intensive and human, was just non-scalable. And so they formed this company, Google, really to organize the world's information, and this is the mission statement, and make it universally accessible and useful. Because in a sense, the progress of humanity continues to depend on our ability to access information. And it was from this sense of mission that Google was born. And it's from this sense of mission that Google has started almost 14 years ago to think about scale, think about data, and how that data becomes accessible and useful to everyone. So I wanted to start a little bit by just talking a bit about Google I/O. I was there last week with some partners speaking and working on a number of areas. But probably the highlight of the whole conference for me was this photo that you can see here on the left of the screen. Now, I don't know if anyone here recognizes this or whether the video is good enough for you to see in any detail. But this is a photo of me with a guy called Jeff Dean. Now, if you're in the tech space, Jeff Dean is famous, and rightly so famous in terms of the big data world, because he was the inventor of MapReduce, this guy here. In one Sunday afternoon, actually, back in 2003, he wrote a load of algorithms to help the development teams at Google work with distributed data and computing. And he published 2 libraries on that weekend, one called the Mapper and one called the Reducer. And very shortly after, this led to the publication of a paper. And here you'll see a chart of some of the papers that have been published. And if you look back at these papers back in 2003 and 2004, 2 seminal papers on the Google file system, which again, Jeff Dean was highly involved in, and the MapReduce paper, which was the paper he published. These were the 2 papers that were taken by Doug Cutting and turned into what is now known as Apache Hadoop. So a lot of the technologies that we're seeing in the big data space, which are making such an impact today, such as Hadoop, were based on the work of this guy one Sunday afternoon back in 2003. It's a very exciting, and it's very exciting, I think, for all of us, and especially us at Google, to see the Hadoop technology get into the market and start making an impact. It's very gratifying to see that some of these tables, both in terms of not just the Hadoop systems, but the publication that was done in 2006 around Bigtable, which led to the NoSQL database movement. And then more recently, we continue to publish papers, one in 2010 on something called Dremel, which I'll talk a little bit more about, and Colossus, which is actually a replacement. We no longer use the Google file system, GFS. It was depreciated some time ago, but for a new system internally. There's also another paper that got published earlier this year, which isn't on this chart, but I think was very relevant to something Sabrina was saying earlier with the diagram of those 3 areas of consistency, availability, and scale, and the fact that at the center of that there is a no-go area, there is no known solution. These are problems which we faced here at Google, And interesting in that space, we recently released a paper about a system that we're working on internally called Spanner. It's very interesting is that it's a global, highly replicated database, and it's designed to give you access on a global scale at low latency and high consistency. I mean, if you're interested in those sort of things, I recommend having a look at that paper on Spanner. It involves nuclear clocks and all sorts of very heavyweight technology to make it work within our data center infrastructure. But you know, this is a moving feast, and every year there are new things coming out, which is very exciting. Now, one other thing worth saying before I move on is, in both of these cases of Dremel and Colossus and more of the recent technologies, we've taken a very different approach, because the fact was we had already written MapReduce and had it running back in 2003. And with a sense that actually with something like Dremel, something like Colossus, we didn't want to wait. If we have these things running, how can we as a company externalize this technology directly so that other people can start using it straight away and reduce that 10-year time span of our starting to use a technology to you in businesses starting to be able to take advantage of this. So some of the other more interesting technologies that perhaps you know, other papers you might want to have a look at. There are some very interesting things that we've been doing around a paper around something called Percolator. This is how we maintain our several hundred petabyte search index, published back in 2010. Again, that was somewhere where we used to use MapReduce very heavily, but now no longer do, because with an index that size, using a MapReduce batch job to generate the index was actually taking 3 to 5 days, which is way too slow. You know, if you publish a web page today, you want it online as soon as possible. So the engineers set themselves a challenge and said, right, let's do it. They brought that time down to 30 minutes to regenerate that index. So it's almost real time. And on average, your new web pages should show in the Google search index within half an hour on average. Other things like Pragal and particularly Dremel, again, were brought in to replace the batch job, which was MapReduce, with something far more interactive. So Pragal deals with social graph data, which MapReduce you can use for, but is very inefficient. Dremel is something which is fascinating because, you know, we are using a lot of interactive query on data, which we use for business intelligence, whether it's managing hard drive fleets or it's managing our search indices. And we wanted to be able to interactively work with data sets of maybe 1 trillion rows of data, you know, which you can imagine we get in the log file in a very short amount of time. So Dremel really is a high-performance query and analytics engine for working on very large data sets. And this is something that we've recently externalized, which is a very interesting thing, is the product that we now call BigQuery, which you can go and have a look if you're interested, is actually externalizing this technology so people can use it, which is quite exciting. So, you know, let me give you a sense of some of the things we're doing. What I've shown here, and this should be a build slide, but for some reason they're not showing in this interface. But let's see if I can get the drawing tool up. You know, every application that Google builds, whether it's search, it's analytics, you know, it's YouTube, or even Google, Gmail, Google Apps, is all built on a single global infrastructure. And this is actually something we don't talk a lot about, but this global comms data center network, it actually operates at a scale which not many people understand, but we're the second largest data network. And Sabrina mentioned the importance of data networks to move data around. You know, we invest in global fiber networks to make this happen. We actually are also the 3rd largest server manufacturer globally. Not that we sell them, but just because we're building them for our own data center fleets. And that's the foundation. It's built in such a way that we can pull a whole data center off that grid, and basic things like the file systems, which are a global file system, this data storage and distribution layer, continue operating as if that data center was still there. So you can think about a massive amounts of redundancy and efficiency, actually. The average data center efficiency is an overhead of about 14%, which and our best data is run at about 6 to 8%, which is world leading in terms of green computing. Obviously, when you have that data in there and secured on an object-by-object basis in the way that this file system works, then you can start thinking about data services. And it's these data services, this is where you find tools like Dremel, things like our predictive and analytics, Pragel, Spanner, all fit into this area. So a lot of our translation systems also operate in this layer of our architecture. And then finally, on top of that, and it's not something I'm going to talk a lot about, but it's worth mentioning here, is we have our applications development platforms. And this is something that's actually really important because the driver of Jeff Dean creating these MapReduce libraries was actually to bring the developers building the applications up here out of the plumbing. So today, 75% of our developers work in this top layer of the stack. Traditionally, it's been almost the opposite way around. You know, you spend 75% of your time plumbing and 25% actually adding value. And the objective, and I think one of the great empowering secrets of Google, is actually turning that upside down. So in our strategy of externalization, at every layer, we're trying to take out the best that we have, the way that we build applications, and externalize them. So if you've used things like App Engine or heard of App Engine, it's actually a complete runtime environment that lets us externalize massive scale computing. So as an example, which might bring this alive, if you take something like Google+, it's built on one of our internal frameworks here, rather than App Engine, which is the externalization of it. But Google+ is a system that we built over a very short time period. And in the first 90 days after launch, we did 100 feature releases to upwards of 40 million users live. So you need huge scalability. You're taking huge amounts of data off that. But if your engineers are playing around with the plumbing rather than building applications, you can never get that level of productivity and rapid innovation and prototyping. And I think this is relevant to a data, you know, when you're starting to experiment with things like data visualizations or data sets, this approach becomes entirely and incredibly relevant. There's actually one of our partners who uses this on a lot of our data services. You know, they're a small company, very, very agile. You know, similar in a way, many ways to Globant. And you know, he won an amazing deal with Philips with these Hue light bulbs. And he was up against some very big competitors. And I remember him saying, he says, you know, when I'm building on these platforms, I'm as big as an IBM. I'm as big as some of these other big established companies. And I think it's starting to allow what is essentially these smaller and agile companies to do some really, really big stuff, which is incredibly exciting, I think. So let's move on and talk a little bit more about the data platforms and data layers. So we've talked a bit about BigQuery already, and I'm going to expand on that a little bit. We also have things like the translation services, the prediction APIs, and this is something that really is just the start. There are so many more technologies that we have in-house that really we're looking at also externalizing. But already there's some very exciting things being done. So a couple of examples. I want to talk about a guy called Tom Newton, who's the director of social gaming at GameSys, based in the UK. These guys probably turn over, you know, a few £billion a year now. Actually, quite a relatively young part of the business. They are launching a big social gaming system. But I think the thing that really stood out for me talking to Tom is you know, his expertise in that data science and data analytics drives his games. Every single thing that's done within this game is measured. So they're tracking, and here are some statistics of, you know, typical games that he shared with some of the attendees of I/O. But you're talking events on a monthly basis. You know, in a mature game could be 5 to 10 billion events a month. And these are events which are driving the complete game development cycle. Now, if you're in gaming, success is critical, and understanding your users is critical. Maintaining your user engagement and retention is critical. And that's just as critical as many other industries. But his opportunity to start looking intelligently at that data is a major factor in, I think, what makes GameSys so successful. So already, even in the beta, the new game, Here Be Monsters, is already generating 200 million plus events a month, which he wants to analyze. So just to give a sense of some of these systems, what he's doing in their game systems is actually generating these events, creating an ETL on a nightly basis, actually, directly into the Google infrastructure, things like cloud storage, and then to BigQuery. The beauty is once it's in BigQuery, suddenly it becomes accessible and really easy to start building on top of. So a lot of their reporting systems, which they actually build on very simple Google spreadsheets, start creating their funnel and retention and growth analysis, is actually done very quickly off AppScript. It automatically refreshes itself every night at 6 a.m. So in the morning, as people come in, they're able to start opening them on their phones, their tablets, their PCs to see what those daily stats are like and whether they need to do game tuning. They also have a couple of other things. So from an engagement and retention perspective, actually, again, built on App Engine using the prediction API, starting to profile and cohort analysis data out of the BigQuery system. It actually just generates, you actually access it using SQL, very simple SQL that you're all familiar with. So very easy to use. But it will generate these reports. And to give a sense, BigQuery will process, a 5 billion row data set query, including joins, including, let's say, regex expressions within a text field, quite complicated queries in those sense. It will process that in about 10 to 20 seconds and give you the results back. So you get this incredible sort of interactive exploration of a data set that otherwise would be very difficult to do on more of the batch analysis approach. And similarly, they use it for their engagement. So they have a mailman system which uses intelligence and starts looking at the profiles of users within the data set. So they maybe say, actually, these users are highly engaged. We know they normally play at certain amounts of times. So you reach out and contact them at the most propitious time possible for them to be most engaged with the game. Maybe you're offering them a promotion or something, you can see some sort of a drop-off. But this classic example of level analysis, of constant tweaking and tuning of a game is something that's critically important to maintaining engagement. I think what is one of the most interesting, engaging, and fastest moving industries that we have that we're working on today. Another example that you may have seen if you were following I/O was also fitted in with some of the things Sabrina was talking, about the Internet of Things, if you like. But there's a very interesting experiment was done at I/O with data sensors, and here you see some examples, 4 examples of some of the data sensors that we put 400 of them around the I/O event. And I'm going to show you a couple of graphs, but because the builds don't work, you're only going to see one. Essentially, we were measuring everything from temperature to humidity to footfall, capturing that data in real time from a Zigbee mesh network, and putting it through the compute engine for some low-level data analysis, and then pushing that up into BigQuery. Then actually, we were using a visualization tool called Tableau, which plugs natively into BigQuery to start visualizing that data. So an example of that would be this graph here, which is actually showing specifically sound levels, and each of these different colors are different floors of the events over 3 floors. And you can see that they ran the evening concert, which is very loud, on the 3rd floor. But you can actually see where a particular sort of, Billy Idol was playing or the Google I/O party kicked in. And starting to track this data becomes, it's a fun sort of experiment, but actually becomes very relevant if you're starting to analyze actual bricks and mortar behavior in, say, a retail store. What's actually happening within that? How are people moving around? And bringing that level of sensor data into a set of tools or technologies like this starts driving a level of interactive analysis that really hasn't been possible until fairly recently as these techniques mature. So just to finish, the final section here, we're looking at the final 2 sections of the storage medium, and here we've got not just the raw storage, we also have things like the Cloud SQL database, Cloud Data Store, and a few other things that would fit into that area. But more interesting also is now in sort of general availability is the Google Compute Engine infrastructure, which really exposes the low-level infrastructure of Google's data center networks. And the interesting thing when it comes to data analysis is actually these were data centers and networks which were built for processing data. So when you start looking at what some of the analysts are saying, but also particularly some of the data vendors, as they're starting to run their tools within the infrastructure, we're starting to get some very interesting results. So here's one from MapR, who were running actually their Terrasort test, and they were trying to break the record. And as you can see, not only did they break the record in terms of speed, which is solely because of the networks within the data centers are incredibly performant. But the impact of starting to be able to run these things credibly within a hosted cloud environment where you get billing by the minute is that you can start running your build times. Instead of having to build the bare metal data centers and provision those servers, which will take months, when you start running them within a cloud data environment, you can start that provisioning in minutes. And last year they showed actually harvesting 750,000 computer cores during the I/O over a 15-minute period from Google's data center network to actually run some gene folding algorithms. Some very interesting visualizations. But I think the most impactful thing, particularly as people are starting to experiment with data and to take that very iterative and incremental approach, is that the cost on a per minute billing of a highly performant environment means that instead of it costing 5.8 million to start standing up your own data center infrastructure, you can actually experiment with this very, very quickly and have that data center for 10 minutes, run some tests, and it will cost you less than $100 in many, many cases. And you see some of the statistics here. And I think that's really what the insight and what's really exciting for me is this sense of the ability to start playing with this stuff, experimenting and seeing what's possible. So finally, I think I just wanted to finish with this idea that Google often was renowned for being one of the simplest web pages on the web, but in order to make that happen, a huge amount goes on under the covers. And it's really exciting, I think, from my perspective, to be part of this sort of movement to start exposing that and externalizing it and see really what people are doing. Many of the examples that I've shared with you here, there are many more. They're just very exciting places to be. And I think this is, in terms of this ability to start dealing really with data rather than messing around with servers and plumbing, is when data science is really starting to come alive. So, from Google's point of view, this belief that really the world progresses through knowledge, and making that knowledge available and giving people the tools to start taking that further and further is a key part of really what Google's about and a key part of what we stand for. So, this is absolutely core. It's really exciting. And, I think as you start experimenting with this in your own businesses, just be aware that what you're standing on really is the forefront, not just of technology, but a real human insight and the future. So thank you very much. I'm going to hand back now to the host here, and hopefully we can then take some questions and answers. Thank you very much.
Hello. We have a couple of questions here. One, I think it's more for Esteban. I will read it aloud. Where do you see the line between utilization data to make decisions and automating decisions making based on the data output?
Hello, can you hear me?
Yeah. Yes.
Okay, sorry. Hello, yeah, I'm hearing some noise background. So I'm partially unconnected here. Sorry. Can you repeat the question, Sabina, so I can because I cannot see it written down on the
Yes,
screen.
if you, where do you see the line between visualizing data to make decisions and automating decision making based on the data output? So I think, and we all three, of course, we can answer these questions. But from my perspective, making a decision at the moment is mostly based on the data you visualize. But we are really a bit far away from making automated decisions based on the data that we see. That's even something else that we can expect from these kind of tools, but I haven't seen something like that as to take actions, automatic actions based on the analytics. I don't know if Matt, you have something more to add, or Esteban?
Yeah, I mean,
on this,
I have a view
question.
here. If you can
This was
hear me.
asked by George Ortiz.
Yeah, I have a view here. If you can hear me, okay. I think there are two. Really, it's about maturity of understanding of the data. You know, an automation decision really comes when you have a sense of understanding, that you know what you want to do and you know how to put that around, you know, those algorithms around the data. But the visualization part really comes in that exploratory phase, particularly is useful there. I mean, it may also come in the automation phase as well. But that exploratory phase where you need to be really having that conversation, that interaction with the data, visualization becomes very important because I mean, you saw some of the graphics that Esteban provided earlier in the presentation. You know, visualization is critical to interpretation, and getting the right visualization can be a big factor in understanding the data itself. The automation then is something that you may take further when you have that interpretation, you have the insights, and you can codify them. So I see it more as a maturity thing of your understanding of the data rather than an either-or situation.
Thank you. Thank you. The next question is, in your experience, what web stack services led the way for interacting with large incremental data sets and visualizing our outputs? So far, we saw really lots of frameworks. They are mostly based on HTML5, JavaScript, and of course CSS3. The general trend is to build different libraries that you can reuse for visualization. And usually they are mostly portable to tablet devices and mobile phones. Of course, the interaction and the portability to them usually involves more UX interaction. So you need to redesign the UI that you build based on that. The screens are smaller, especially on the mobile screens, and usually that involves pagination, for example, and different other usability tips that you need to take into account to port them to this type of devices. But at least from the code perspective, and of course the backend is completely reusable. I'm not sure if Esteban or Matt has something else to add on this.
I can certainly add something from, I suppose, our experience of what I'm seeing in the field. I think, like you, we're seeing a lot of people who are really, building these frameworks because they want them to go into the mobile devices where they want something very light. I think where they want something very creative. It's a very exciting space, very fresh. We're also seeing, I suppose, visualization tools like Tableau and to some degree QuickView really coming into their own here as well, where they're able to integrate directly onto some of these big tools on the back end and sort of allow a visual data analyst to start playing with it without having to understand directly the complexities of some of the back-end tools. So the examples I showed earlier, those charts from the data sensing lab were actually coming from a Tableau installation. So it's a whole range. The GameSys guys, they build their own. They build their own visualizations, exactly as Sabrina was discussing.
Thank you, Matt, for your insight. And the last question is related to OLAP. When you work with OLAP tools, what transformation does the obtained data suffer in order to be able to manipulate them? Do you have to structure them before they are stored in a data warehouse? Let me see if I understood the question. Okay, the idea is to use structured data that you already have in maybe any of the business intelligence tools in order to continue doing analytics. We've done that, ingesting the data that comes from, for example, an Oracle BI tool. Usually we use frameworks like Scoop to ingest them to central repository and actually enrich that with unstructured or semi-structured data. Usually you don't need to transform that. We take the structure as it is, and no further transformation needs to take place. But depends on the type of analytics and the conclusions you want to perform. Sometimes you need to cleanse the data and put it in a specific, for example, if you are trying to do predictive analytics, you need to set up an array-like structure in order to train the neural network. So sometimes it requires transformation, but usually if you're trying to do more static type of analysis, this is not required. You can ingest and actually use the data as it is.
Yeah, I think I'd add to that. Exactly.
Yes.
Sabrina
If you want to add, you want to.
Yeah, I think there's 2 points maybe I'd say is, what I'm seeing, you take, Dremel as an example, BigQuery as it's known externally, and it actually is minimally structured. So what typically you would see in a data set is a massive wide denormalized table, single table. You can have multiple tables, but, I've seen tables 1,000 columns wide. Which works very, very well particularly with the sort of telemetry-like data that you're getting off a lot of these big data systems. So, traditional data warehouses have required highly intricate structure. They're highly relational, and this actually causes a lot of issues both in terms of query performance, but also in terms of the data preparation and ingestion. So reducing that burden is very important. Dremel actually takes these broad tables. It also takes sort of JSON structured tables as well, so you can have elements of free-form fine structure within them that can be queried. But I think there's another point beyond that, which is, I think typically large data analysis within data warehouses, but also within analytics tools, have taken an approach of sampling or aggregation of data, so that you actually lose a granularity. And for a lot of people today, this is becoming a major issue. You need to get down to the actual data points themselves, because the insight isn't in the average, it's in the outlier. And unless you can navigate and find those outliers, you really don't get the insight you're looking for. So, moving, I think the real whole big data movement is exciting in this respect, because it allows people to work with the low-level telemetry data streams, which actually is where the insight is found. Analytical functions, analytical tools are looking for these sort of moving away from that traditional mindset of what data warehousing is, of highly relational databases, of highly structured data. So move with much more real-time, lower-level streams of data, but still drive out insight at scale.
Thank you very much, Matt, for participating in this webinar. Thank you, Esteban, as well. Thank you for the audience also for taking the time and for all the questions. We will send out the recording and share the presentation with you all. And of course, if you have more questions to come, please send them to me, and I will forward it to Matt and Esteban as well, so we can continue this conversation. Thank you very much. Bye.
Thank you.